start recording. Okay, there we go. Okay, so yesterday, now, okay, so now before we start, I hope you have had some chance to read my long speech, and I hope it deserves kind of like standing ovation, but I don't know.
Yeah.
So if you didn't or haven't read it, just read it later. Okay, it's kind of like lengthy, and maybe it's like more like State of the Union address or something, but State of the Exam address. Anyways, so I already got 2 questions this morning about thinking about dropping the class. And remember, as I said in that speech, failing 1 exam is okay, but maybe failing 3 exams, that's gonna be a problem. And even in the past, some people have failed 2 exams, but they still ended up passing the course. So failing 1 exam, oh, that's completely fine. Now, of course, there could be some people who feel that this course is just too much and I can notice that, so I know I have to drop out. Okay, now that's your decision. But of course, I have to, or I can offer some advice if you want. So my point is just to wait until the drop date, which is 17th, I believe, which is next Wednesday, I believe, but I may have to double check. So just wait and see how you do and how you perceive the course materials. And if you feel like this is getting too much, then you can think about dropping at that time, but you don't need to drop like right now, today, okay? So that is my another advice on top of that, like millions of advices that I put on that speech. But so yesterday, so what we are doing is, so we have looked at these 4 new functions from FNG, the sum, so addition and subtraction, multiplication, and the division of functions. And we are trying to do this problem. So f was 3x minus 4 and g was 2x plus 1, and we have to find each. And remember, in part A, the input, the x value was the number, and in that case, we don't have to find this new function, okay? So we just have to use the definition, okay? So that is plug in the 0 to f and g and then add at the end, okay? So we will use the same strategy as long as the input is a number, which is the case for the next 3 parts, as you can see, okay? So for f minus g of -4, once again, that input is a number, okay? So no need to find f minus g, okay? So here, by definition, f minus g of -4, okay? So that means f of -4 and then minus g of -4, remember, okay? So what does that mean? We plug in -4 to fng and then we will subtract, okay? Now, I have copied fng on top of the paper because we cannot see those 2 functions, which is on the previous page. So f of -4. So what does that mean? So that's -12 minus 4, so that's what, -16, right? And then g of -4. G of -4, so that is what, -8 plus 1, so that's -7, right? Okay, now, does this mean, so now from here, does this mean we have -16 minus 7? Is that the case? No, right? Be careful, because what does this mean? We subtract 7 from -16, but we have to do what? We have to subtract -7 from -16, so it's that, right? Okay, which is what, -16 plus 7, which is equal to what, -9, right? Okay, so whenever you're dealing with subtraction sign, be careful to deal with possibly the double negatives which turn into the plus sign, okay? Okay, so -9 is the answer for B. And then C, FG of -2. Okay, so once again, that X value is the number. Okay, so we don't need to find the product function FG. So again, by definition, FG of -2 will be F of -2 times G of -2. And the same strategy. So what do we do? Plug in -2 into F and G respectively. And then at the end we multiply, right? Okay, so what is F of -2? Okay, so F of -2. So that's what, -6 minus 4. So that's what, -10. Okay, and then G of -2. G of -2 is what? -4 plus 1, so -3. Okay, and now what we do with these two numbers, we are multiplying them, right? Okay, so what is the answer? Positive 30, right? Okay. Okay, so now the next part, F over G of 3. Okay, so now I'm not sliding this paper too much because I want you to see the F and G. So F over G of 3. Okay, so again, that input is a number. So what do we do here? So by definition, this is F of 3 over G of 3, right? Okay, by definition. Okay, so now, what does that mean? So F of 3. So we have to plug in 3 into F. So what is that? 9 minus 4. So that's what, 5, right? Okay, and then G of 3. So that is what, 6 plus 1. So that's 7, right? Okay, so now that is the answer, which is pretty simple. Okay, now be careful when you get something like this. So if this were the answer, quote unquote, what do you have to do at the end? Reduce, right? Okay, so when you plug in like a number to F and G or G over F, like whichever you are given, let's say you got 15 over 18 as the answer, then that's not the final answer, right? Because you have to reduce it, okay? Okay, so you have to reduce it. So be careful. Okay, so that means like whenever you plug in a number to F and G and then put them in a fraction, that may not be the final answer, okay? Because at the end you may have to reduce it. Okay, now here we can't reduce, so that was it, but that may not be the case all the time. Okay, so now what do you notice from these 4 problems, or what, 3 problems? No, 4 problems. Yeah, I need to wake up. So from these 4 problems, what you can notice is whenever input is a number, then you don't have to find the new functions, whether it's the addition, subtraction, multiplication, or division. Now, what could happen, and these are the types of problems that I like it because that's not that trivial. The general functions, f plus g and its domain. Okay, so remember, you will be asked to find the domains of these new functions. Okay, so what do we do here? Well, still the first step is the same, okay? So f plus g, so what does that mean? f of x plus g of x, right? Okay, add f and g. Okay, so now what was f? 3x minus 4, right? And what was g? 2x plus 1, right? And now what do you have to do with these two? We add, right? Okay, so now remember, you have to always check whether you can simplify some expression at the end. And here, can we simplify this 3x minus 4 plus 2x plus 1? Yeah, right? Because they are like terms, right? So what does that mean? Combine these two and these two. So what do you get? 5x minus 3, right? Okay, and that's it. So that is the sum function f plus g. And again, never set that equal to 0. Okay, don't set this equal to 0. That's it, right? Now, the domain. Okay, now, can you see what the domain of this 5x minus 3 should be? And let me see if I can find that paper. So remember, the domain is the x value, so I guess we all know that. Now, here is my little hint thing. So what did we say in the past? The domain is mostly something, but the two exceptions are the square root and the rational case. Okay, so can you see what the domain of 5x minus 3 is?
Negative infinity, comma infinity.
Everything, yes. Do you see why? Because there's no square root, there's no rational. Okay, so the domain is everything. Again, the reason is no square root or rational. Okay, so you always have to check for these two things. Okay, so whenever there's no square root or rational function, the domain will be everything. Now, f minus g. Okay, so that means f of x minus g of x. And now, f of x was 3x minus 4. And then g of x was 2x plus 1. And then we subtract. Right? So the answer is what? X and then minus 3. Right? Right?
No, because you'd have to multiply the negative sign into each quantity because you technically have parentheses around.
Did everybody hear that? Okay. So now, so many people write 3x minus 4 minus 2x plus 1. But we are not subtracting just 2x from 3x minus 4, right? We are subtracting the quantity 2x plus 1 from 3x minus 4. So you have to put a parenthesis, or just make sure whenever you are seeing the subtraction sign, you have to distribute this negative sign to whatever comes second. Okay, so it's 3x minus 4 minus 2x and then minus 1. Okay, so what's the answer? X minus 5, right? Okay, not x minus 3. Okay, and now the domain. What's the domain? Is it the same as before, the previous one? Or is it different? It's the same, right? Yeah, okay. And what's the reason? Same reason, no square root or no rational. Okay, same as before. And now fg and its domain. Okay, so now fg means what? F of x times g of x, right? Okay, so f of x was what? 3x minus 4. And then what was g? It's 2x plus 1, right? Okay, so we are multiplying these two. So now, how do you clear parentheses? What's the only way?
Well,
FOIL, right? Okay, so what do you get? 6x squared plus 3x minus 8x minus 4, right? Okay, so combine like terms, 6x squared minus 5x minus 4, right? Okay, so now, what is the domain of this rather complicated looking function?
Would it be the same?
Same, yeah, right? Why? No square root, no rational, okay? Even though we have this like exponent 2, the domain is still the same. Okay, so that was the product function. And now, the last part, h. So I guess you can guess what the last part should be. It's the quotient function, f over g. Okay, so f over g. And its domain. Okay, so now, this means what? F of x over g of x, right? And what was f of x? 3x minus 4. And what was g? 2x plus 1, right? And now, what did I say yesterday for these quotient functions? You don't have to simplify. Okay, so what does that mean? You wrote f at the top and g at the bottom? That's all. Woo. You don't have to simplify. How nice is that? Oh, okay. So that was easy. The domain is also everything, right? No, okay. Why not? Because do we have one of the two special cases that we have to be careful with? Yes. What do we have? Rational, right? Okay. So the domain is not everything. Okay. So now, do you remember how to find the domain of the rational functions? So basically you have to look at, oh, so we have a fraction. So you have to ask yourself, how can a fraction go wrong?
in the denominator,
Okay, so what about the denominator?
if the denominator is 0,
Then it's not good, right? Yeah, so what do you have to do? Find the so-called bad values, right? Remember that? So you set the denominator equal to 0. Okay, so what do you get? Subtract 1 and divide by 2. So you can easily verify that you get x is equal to -1/2, right? Okay, so in particular, what does this mean? X cannot be equal to -1/2 because that's the bad value, right? Okay, so what's the domain in words? The domain is what? Every x but negative 1/2, right? Okay, now how do you put this into the interval notation? So remember, you should always start from the negative infinity, the smallest possible case, okay? Whose symbol is what? Parentheses, right? Okay, and now you have to walk toward the positive x direction. Now, at some point, you'll hit negative 1/2. But what does that mean? Do we have to put bracket or parentheses? Parentheses, right? Why? Because it's a bad value, right? So we shouldn't include that. And now, when you jump over negative 1/2, are you good to go to the positive x direction? Yes, right? So it's negative infinity or negative 1/2 comma infinity. And remember, you cannot put a bracket here because then you are including negative 1/2, which is a bad value, right? So what does that mean? Another parentheses and then parentheses, right? And then in between these two intervals, that you think, right? Okay. Okay, so remember the quotient function is the easiest to find, but you have to be careful with finding the domain because in 99.9% of the cases, the domain won't be everything. Oh, so you have to ask, then what about that missing 0.1%? Can it be everything? You'll see. I don't know. Okay, so any questions over this long problem number 1? So what do you notice in this problem number 1 here? The tricky thing is the difference function because of the possible switching signs thing, and then the product, and then the quotient. Okay, and then finding the function values, it's fairly straightforward. Okay, so look at number 2 and number 3, which is on the next page. So the function changes, but that's not the only difference. We have to find the difference, product, and the quotient functions, the general functions, and their domains. Okay, so we'll do the same thing, f minus g. So this is f of x minus g of x. Okay, and f of x was x squared minus 3x. And remember, if you don't want to deal with parentheses, what do you have to do? So as soon as you see the subtraction sign, you have to make sure to distribute it, right? Okay, so what does that mean? It's minus 2x squared. And then instead of plus x, it's minus x, right? And then instead of plus 1, it's minus 1, right? Okay, so that's the way to avoid parentheses, but you know, if you want, you can do that and then clear parentheses. So now, do we have like terms? Yeah, right? So what do you get? Negative x squared for these two, and then these two, they become what? Minus 4x minus 1, right? Okay, so that's it. And again, never set that equal to 0 and solve. That's all. Okay, and now, what's the domain? Is it not everything or is it everything?
It's everything.
It's everything, right? Yeah, due to the same reason. Okay, so now fg. So that means multiply f and g. So that is x squared minus 3x, and then times 2x squared plus x plus 1, right? Okay, so now, hopefully you know that to clear parentheses, we must FOIL this, right? So that's not hard to see. But here comes the main question. How do we FOIL this? So first of all, what is the F term? So this is not the standard FOIL, but still, it's easy to see what F should be, that F. What should F be? The first terms.
X squared times 2x squared.
And what do you get? What is x squared times 2x squared?
2x to the 4th power.
2x to the 4th power, right? Yeah, okay. So it's 2x to the 4th power. And now where do you go? Next.
X squared times x.
That, right? Yeah, which is equal to what? X cubed, right? And then where do you go?
X squared times 1.
That, right? Yes. Okay, so plus x squared. Okay, and then you go to the inside, right? So this times that. So what is this? Minus 6x cubed. Okay, and then these two, minus 3x squared, and then these two, minus 3x, right? Okay, so what do you notice here? That's FOOIL. Okay, and hopefully you have seen this variation FOIL before. So remember, you could have multiple O's and multiple I's. Okay, so now like terms. Let's see, we have these two like terms, these two like terms. So what's the answer? 2x to the 4th minus 5x cubed minus 2x squared minus 3x, right? Okay. Now here, you don't need to take out an x, which is the GCF. There's no factoring here. Okay, so that's it. Okay, that's it. Now, what is the domain of this ugly looking function?
The same as the one before it.
Everything, right? Yeah, okay. Okay, so now, f over g and its domain. Okay, so this means f at the top, g at the bottom. So x squared minus 3x over 2x squared plus x plus 1. That's all. You don't remember, you don't need to simplify the quotient function any further than that. So that's really good. And now the domain. So how do you find the domain of this quotient function?
Set the denominator equal to 0.
And solve, right? Yes. Okay. So it's this 2x squared plus x plus 1 is equal to 0. Okay. So now, this is a quadratic equation, remember? So the first thing you have to check is, can you factor this? Yes, you can. Okay, so what are the two factors? Is it x plus 1 times 2x plus 1? This one? I don't think so, because when you follow this, what do you get as the middle term? 3x, right? Okay, then is it this one? Mm-mm. So, can you factor this? No, okay, you can't. So, what's the only way to solve?
Quadratic equation.
Yeah, that formula, right? Yes, okay, so quadratic formula. So, let's see, quadratic formula. So what do you have to do? Identify A, B, and C. So A is equal to 2, B is 1, C is 1, right? Okay, so plug them into the formula. So what do you get? X is equal to negative B, so that is negative 1, right? And then plus minus square root of B squared, right? So 1 squared minus 4AC, so that's 4 times 2 times 1. And then everything over 2a, which is 2 times 2, right? Okay, so now, what is the number under the square root?
-7.
Negative 7, right? Yeah, 1 minus 8, right? Yes. Okay, so we see a negative number under the square root. So what do you have to do? Take the I out, right? Okay, so it's negative 1 plus minus square root of positive 7i all over 4. Okay, so now, how many bad values did we get?
2.
2, right? Are you sure? Now, why am I asking that? Because the bad values matter for the domain. And in particular, the domain matters for the graph. Now here, this was the range, but still the domain makes sense for the graph, which exists on the xy plane. Now, on this xy plane, where do you see an I? You don't see it, right? Because it's not there, right? Okay, so how many bad values did we get? None, right? Okay, none. There is no bad value. These are not the bad values. Since they have an I, okay? So what's the domain then? So we were trying to find the bad values, but there wasn't any. So what's the domain?
Everything.
Everything, yes. Okay, so what do you notice here? Even though we had a rational function, the domain was everything. And that's why I said earlier, it's 99.9%. The domain is not everything for rational function, but where is that 0.1%? Here we go. Okay, so there could be an exception, okay, but in most cases, the domain is not everything, okay? So that was the tricky thing. Any questions over this number 2? Okay, so now, if you thought question number 2 was trickier, well, sorry about that. Number 3, that is something. That's something else, okay? And hopefully you can see why. Do you notice why? You have, wait, what's going on? Oh, okay. So let's see. I don't know why you can see it. There has to be something that's messed up. Okay, so f of x is, can you see it clearly on your side? Something is messed up with my Zoom. Yeah, I don't know how I fix this, but so f of x is square root of 2x minus 1, square root of 2x minus 1, and then g of x is 1 over x, okay? And now you have to find each. Try to fix it, but somehow it's not working properly. So now, the thing is, you have to find the exact same functions, f minus g and its domain, and then fg, and then f over g. Okay, so the difference, product, and the quotient functions. Okay, so there we go. Okay, so now you can see it. Yeah, welcome to Thursday. So here, what do you have to do? Subtract, right? Subtract. So square root of 2x minus 1, and then minus 1 over x. Okay, so now, here comes the first tricky part. There will be like lots of tricky part here in this problem. Can we simplify this further? So in other words, are there any like terms? No. And what's the reason? These two are not like terms because this is under the square root. Okay, so there's no way that you can simplify this further. Okay, so for the product or the difference function, we couldn't simplify. Now, the domain, that is the tricky part here. So here, is the domain everything? No. And what's the reason? Because do we have a rational function here? Do we have square root? Yes, we have both. Okay, so what do we have to do? Let's look at each piece separately. Okay, so let's look at the square root part. Okay, so now what do we know about the square root? How do we find the domain? So for the square root, what do we do? Set whatever under the square root to be greater than or equal to 0, right? Okay, remember that? Yeah. So what does that mean? This, right? Okay, and now you have to solve it. So what do? You add 1. So that's what? 2x is greater than or equal to 1, right? And then you divide by 2. Now, when you divide by 2, do you change the sign of the inequality? No, right? Because we are dividing by a positive number. So x is greater than or equal to 1/2. Okay, so that's the domain for the square root part. And now let's look at that rational part, 1 over x. So here, it's really the simplest rational function, right? So I hope you can see the only bad value, right? What's the only bad value? 0, right? Okay, so what's the domain? It's everything but 0, right? That's the domain for the 1 over x. Okay, so now on the number line, let's try to see what's going on. So here is 0 and here is 1/2. Okay, now the square root part says x is greater than or equal to 1/2, so that means we have to shade this one, right? With the closed circle at 1/2. Okay, so that's what x is greater than or equal to 1/2 means. And then the rational part says everything but 0 is the domain. So what does that mean? It's the empty circle at 0, and then we shade where? Everything else, right? Okay, so that's this, right? And now we see the two shaded regions. What do we have to find? I think you can guess it even. What's the next task? Like from these two shaded regions, what do we have to find? Where they what? So there's a reason that I shaded two regions on the same number line, okay? What do you have to find here?
Don't you have to represent it in interval notation?
Yeah, we'll do that, but first we have to find something. So there are two shaded regions, and like I said, there's a reason that I shaded on the same number line. So look at some of the portions on the number line, and there is some, I guess, interesting thing going on. So another hint is some portions on the number line is shaded once. Some other portions are shaded twice.
They overlap.
The overlap, yes. Okay, what's in common, basically. So where is the overlap? Right there. Okay, so now where is the overlap? Anything greater than or equal to 1/2, right? Okay, so that's the overlap. And what's the interval notation of this? Bracket 1/2 comma infinity, right? Okay, so that is the domain of this product or the difference function. Okay, tricky, right? So now, there's the good news. We did the hard part. So now, look at part B. It's FG and its domain. Okay, so FG. So this means f of x, which is square root of 2x minus 1, times 1 over x, right? Now, I claim that there is a way to rewrite this. Can you see how to multiply or how to simplify this product? And here's my similar problem. How do you multiply square root of 2 by 1 over x?
Rationalize the denominator.
Rationalize the denominator? Oh, that's too hard. No. Like, what is square root of 2? Like, how do you multiply square root of 2 times 1/3? What do you do?
Do you put a 1 under the 2x minus 1 squared?
And then?
Multiply
Yeah, how?
across.
Like that, right? Yeah, okay. So, it's square root of 2x minus 1 all over x. Okay, and be careful, we cannot cancel these two x's, right? We cannot do that. Why? Because the top x is under the square root. Okay, so it's just that. Okay, so now the domain. Now, again, this is a mixture of what? Square root and the rational. Do you see that? We have a square root, and this entire thing is the rational, right? Okay, now, remember I said earlier that we did the hardest part. So, what is the domain for the square root part? Is it same as before? Yeah, it was this one, right? And now, what about the rational case? So, for the rational case, what do you have? That over x, right? So, what's the domain? Same thing, right? Everything but 0. So what should be the domain of everything then? The domain of everything should be what? Also same as before, right? Okay, because even though the function is different, like function looks different, it's consisted of the same kind of pieces, so that's why the domain is the same. Okay. And now the last one, f over g and its domain. So this means what? Square root of 2x minus 1 all over 1 over x, right? Okay, f over g. And now, have you seen this kind of fraction before? Fraction inside a fraction. Have you seen that? Do you know the way to simplify this? So like, for example, if you have like 3 over 1/2, how do you simplify this?
You multiply 3 by 1/2.
So, multiply 3 by 1/2? Not 1/2. Yes, we multiply 3 by something, but not 1/2.
Do you flip the fraction?
Flip which fraction?
The
The top one or the bottom one?
The bottom one.
The bottom one, yes. Remember that? So you flip it, and then you multiply that to the top, right? Okay? So what does that mean here? It's x over 1 times the top, right? And what is x over 1? Just x, right? Okay? So it's x times square root of 2x minus 1. Okay, so now, what is the domain of this? What's the domain of this? So now here, we don't have a rational function, right? But we just have a square root, right? Okay, so we just have the square root case. But did we already get the domain of the square root part earlier? Yeah, right? Because what do you do? I mean, do the same thing, right? 2x minus 1 is greater than or equal to 0. Okay, so in the end, what do you get? X is greater than or equal to 1/2, which you already got it, right? Whose interval notation is what? Same thing. Okay. So we did the hardest part in part A, and then the domains for B and C were exactly the same. But of course, the functions were different. Okay. Now, the reason I did this problem is because in the homework, you will see the square root and the rational function case like this. But personally, I'm not a big fan of this kind of problem because it's just too tricky. And I guess you know what that means at this point. But anyways, if you don't, then whatever. So that's it. And now let's look at a lot simpler cases. So now this is the next problem. Using the figure below, find f plus g of 2. Okay, so now here you are given some tables of x and the outputs for f and g. Now, f plus g of 2, remember that number is the input, so it's f of 2 plus g of 2, right? Now, how can we find f of 2 and g of 2 since we don't know the equations?
Look on the table.
And which row are we looking at?
The x equals 2. The third.
That one, right? Yeah. Okay. So when x is equal to 2, we know the outputs, right? So what is this? 7 plus negative 2, 5. Okay. And now f over g of 0. Okay, so what does that mean? It's f of 0 over g of 0. So now, which row do we have to look at? The one above, right? And what is f of 0? 5. And g of 0 is 0, right? Okay, so now, what is 5 over 0?
Undefined.
Undefined, right? Yeah, it's not 0 or 5, right? Yeah, it's undefined. Okay, so simple problems after some tricky ones. That sounds very suitable. Okay, now the next problem. Instead of having the tables of values, now we have graphs. Okay, so now we have graphs of f and g. So find fg of 1. Okay, so fg of 1. So what does that mean? F of 1 times g of 1, right? Now, what is f of 1? Can you see it from the graph? So the blue graph is f of x and the red one is g. What is f of 1?
One half.
1/2? So here's 1. And now you have to go what? Go to where the blue graph hits 1. And what is this value?
2.
2, right? Yeah. And what is g of 1? 1, right? Okay, so 2 times 1, 2. Okay, that's it. And now, f minus g of negative 1. So this is what? F of negative 1 minus g of negative 1. And now, where is negative 1? Here, right? So what is f of negative 1? And what is g of negative 1? Is that a tricky question? F of -1. So what do you have to do? Go until -1 hits -1, or I'm sorry, -1 hits f of x, right?
So it's -2 minus 1.
Right? So it's -2, and then g of -1 is 1, right? So it's -3. Okay, so I mean, as long as you look at the graph, it's fairly straightforward. Okay, like there's no tricky thing here. Okay, so can I go to the next page? Okay, so now there are 2 more topics to go. So here's the next topic, the difference quotient, which I always call it DQ, not the Dairy Queen, of f of x. So now, if you have to take calculus in the future, now how many of you have to take calculus in the future? You don't know? Maybe? Maybe not? Okay. Now, if you have to take calculus in the future, you will see this once again. But what does difference quotient mean, first of all? The difference quotient is f of x plus h minus f of x all over h. Which is rather looking quotient. Okay. Rather a kind of weird looking quotient. So now, so notice that the denominator h is same thing as x plus h minus x. Okay, so now what does that mean? We can write x plus h minus x like this. Okay, and now let me put parentheses like this. Okay, so let me call it x1 for x plus h and x2 for x. So what do you see? It's f of x1 minus f of x2 all over x1 minus x2, which is kind of similar to what? y1 minus y2 over x1 minus x2. Now, have you seen this kind of fraction before? y1 minus y2 over x1 minus x2. Does it look familiar? What is the name of this fraction? So usually I play hangman in this case, which is what, like revealing each syllable one at a time. So starts with S.
Is it slope intercept?
Oh, take out one of the words.
Slope?
Slope, yes. Okay, so the difference quotient is same thing as the slope, but again, the real difference quotient is it's kind of messy, but once again, f of x plus h minus f of x all over h. Okay, it's this one, not this. Okay, so now let's look at the following 2 problems. So what you have to know for this class is knowing how to evaluate the DQ, the difference quotient, for a few functions. Now, when you work on the homework problems about this concept, you will see that your homework is consisted of 3 parts. Number 1, half of the numerator. Part number 2, the entire numerator. Part number 3, the whole difference quotient. Okay, so I will do the same thing here as well. So f of x plus h. What do we do here even to find f of x plus h from negative to x plus 4?
identify x and h?
Okay, so remember we have seen this thing before. And let me see if I can find it. Was it this one? Yeah. Yeah. Does it look familiar? So, what do we do here then? So here, what's the input? The thing that needs to be plugged into X. That whole thing, right? Okay, so that's the input. So what do? Replace X by X plus H, right? Okay, so what do you get? -2 stays the same. And then, instead of X, what do you have? Times X plus H, right? And then plus 4, right? Okay, so now, can you clear parentheses here? Yeah, right? So what do? -2x minus 2h plus 4, right? Okay? And now, part number 2, the entire numerator, f of x plus h minus f of x. So now, what is this? Remember, you're seeing the subtraction sign in between these two functions. So what do you have to worry about? That, right? Okay, so f of x plus h is what? -2x minus 2h plus 4. And now, is it minus 2x or something else?
Minus x minus h.
Well, yeah, so like -2x minus 2h plus 4, and then when you subtract f of x, which is this one, is it minus 2x plus 4, or is it something else?
It's a x plus h.
Well, x plus h is changed into this one. So we are done with this, and now we are taking care of this part. So it's, again, is it this one or something else? No, right? What is missing here? That, right? Okay, so minus -2x plus 4, right? Okay, be careful. You are subtracting f of x, so you need parentheses, right? Around f of x. So what is this? -2x minus 2h plus 4, and then plus 2x minus 4, right? Okay, you are changing the sign, right? Okay, so now, can you simplify this further? Yes. What is going on? Canceled, right? Okay, so you're left with what? -2h, right? Okay, so now that is the numerator. And now what is the final difference quotient? So this is equal to what? -2h over h, right? And now, is there a way to simplify this further? How do you further simplify? What's the only way? That, right? Okay, so what's the answer? -2. Okay, so -2 was the difference quotient. And now, going back to the original function, what does -2 represent? number in front of x, right? And if you remember from your previous math classes, I believe, that is same thing as what? The slope, right? Because it's the m, right? Okay? So now, going back to this earlier comment about the difference quotient, if you are, or you have done your math right, you will see lots of cancellations at the top. Okay, so that is the key thing. So here in this part A, we saw 4 cancellations, but you'll see that things can be much more than that. Okay, so if you don't see any cancellations on your numerator, you know something is wrong. Okay, so now part B. Okay, so now this one is kind of tricky. So first one, f of x plus h. Again, this means what? Replace x by x plus h. Replace x by x plus h. So what does it mean? 2 stays the same. And then instead of x squared, what needs to be squared? X plus h, right? And then plus 3 stays the same. And then instead of x, what do you have? Times x plus h, right? And then minus 5 in the back, right? Okay, and now, how do you simplify this first term? What do you do first? Distribute 2 or take care of the square first?
Square.
The square first, right? Yes, okay, so we do this one first. And now, hopefully you remember how to simplify this. So what is this? X squared. And then, what is the middle term? So it's xh and then hx, right? And they're the same, right? So what is this? 2xh and then h squared, right? Okay, and now, there is something in front, which is 2, right? And that means this, right? Okay, so what do you have to do? Distribute 2, and then distribute 3 for the second term, right? So what do you have? 2x squared plus 4xh plus 2h squared, and then plus 3x plus 3h minus 5, right? Okay, now, is this the entire numerator? Because it looks long enough, right? Is this the entire numerator? No. And what's the reason? We haven't seen any cancellations, right? Okay, remember you will see cancellations if you have done your math right, but at this point we haven't seen any. So what is the numerator? You subtract f of x from this. Okay, so what is this? Well, first you copy what's written at the top, this one, and then remember you are subtracting f of x, right? So now, how do you not worry about the parentheses? You have to change the signs on f of x, right? So what does that mean? It's minus 2x squared, okay? And then it was plus 3x, so that becomes minus 3x, right? And then it was minus 5, so that will become plus 5, right? Okay? Now, so do we see any cancellations? Yes, so these two are canceled, and 3x minus 3x are canceled. Minus 5 plus 5 is canceled, right? So here, what do you see? There are 6 cancellations, which is a lot, okay? So what are the survived terms? 4xh plus 2h squared, and then plus 3h, right? Okay, so that is the numerator. And now, what is the entire difference quotient? You divide these things by h, right? So what is this? 4xh plus 2h squared plus 3h all over h, right? Now, how can we simplify this? Is there anything in common? Yes, what is in common? The h, right? Do you see that? Here is h squared, here is h, right? So what do? Gone, gone, gone. And now, what happens to this h squared? Is the entire h squared gone?
It would just be 2h, right?
Right? So only one of them is gone, right? Okay, so it's 4x plus 2h and then plus 3. And then at this point, there is no like term, so that's it. Okay, so this is the trickier case than A, but this is more important, unfortunately. Okay, unfortunately. So even though it is trickier, this is more important. Okay. Any questions about this difference quotient? Okay, so now off to the last topic in the section, composition. Okay, so now earlier we saw some difference product and quotient functions, and this is the last one, okay, that we can get from f and g. Okay, so here is the definition of the composition. So for f and g, the composition of f and g, the notation is f circle g. Okay, so f circle g. So here, the formal pronunciation is f composed with g. But normally, people say, including myself, f circle g. But then some other people who are even lazier than me says fog. Okay, that's fine. Okay, fog. Now, you can choose to pronounce as fog, but you have to be a little bit careful on your pronunciation, because if you pronounce fog too harsh, then it kind of sounds like that prohibited F word. Okay. Okay, whatever that F word means. So you have to say fog, like very smoothly. Okay, like you cannot say fog. Okay. So be careful, a little bit of pronunciation. Anyways, so that's not the point. But, so since this is a function, it's the composition function, so we have to have this of x notation. And now, what does this mean? F parentheses g of x. Okay? And now, some people tend to think that f circle g is a multiplication, but that's not the case. Okay, rather what do you have? You have your g, and that's inside your f of x. Okay, so now, here is the illustration of this composition, f circle g. So suppose there is a machine, and its name is g. Okay, so here's a machine. And now here is the ball, which is an X. Kind of looks like a baseball. Okay, I kind of missed the baseball season because it's on hold right now because of this stupid pandemic. But anyways, so here's the baseball, which is X. And now this ball is inserted into the machine G. Okay, and it will produce an output. which is another ball, and it is called g of x. So that is the output for g. And now, when you normally get the output, you are done, right? However, for this composition, what is going on is right underneath this machine G, there is a machine F. It's well placed, so well placed that it's ready to accept this output as the new input. So what does that mean? That output for G becomes input for F. Okay? And finally, at the end, there is this final product, final output, and that's called f of g of x. Okay, so in short, what does composition function mean? Going through function twice. Okay, not the multiplication, but you are going through the plugging in thing twice. Okay, and now, going back to this F circle G here, what do we do first, F or G? Based on this picture, what do we take care of first? G, right? Okay, so we do the inside function first, and then we go to the outside. So frequently, what I will draw is something like this. And hopefully you can see why. Okay, because you plug in the second function into the first one. Okay, not from first to second. Okay, so be a little bit careful here. The order is backward. Okay, so now a few remarks. We can swap F and G, namely G circle F. Okay, then what does it mean? So from this definition, when we swap F and G, do we have to swap F and G right here? Oh yeah. So now, what is the outside function then? It's G, and then inside function is f of x, right? And now, do we still do the G first? No. Now, since f is the inside function, we do it first. Okay, and again, we are doing this. Okay, so G is not always the second function. G could be the first function. Okay, now f and G might also be the same. So we may also have f circle f and G circle G. Yeah, so that's why some people say fog, golf, fof, and gog. Yeah, so it's kind of like 4 alien words like fog, golf, fof, gog. Yeah, you can say that to your friends and see what they think. Yeah, most likely they'll think you are kind of a little bit crazy, but whatever. You are talking about math, which is legitimate, so you are good to go. Anyways, so now, just like the product and quotient and sum and difference functions, you have to simplify each composition function as far as possible, and you'll be finding the domain as well. Okay, same thing as before. So let's look at the following problems. So suppose f is 3x minus 4 and g is negative 2x plus 1. Find the followings. F circle g of 0. Okay, so now we have seen, where is my paper thing? I cannot find. Okay, so now, anyways, we have seen the problem. Okay, there we go. We have seen quite a similar problem before, right? So whenever an input is a number, we don't find the resulting new function, right? Now, can we do the same thing here as well? Yes, because that is the input, which is a number, But we are not finding f circle g. Why? Because by definition, what do you have to do? Plug in 0 into x, right? Which means plug in 0 into x here as well, right? So what does that mean? F of g of 0, right? You see that? Okay, so by definition, this is f parentheses g of 0. Okay, and now remember, what do we do first? You always have to draw this arrow, right? So what does that mean? Do that first, right? Okay, not f, right? So what is g of 0? G of 0 is what? 1, right? Now, is 1 the final answer? No. Now what do you have to do? Plug that into f, right? Okay, remember you are plugging in twice, okay? One into g and then the other into f, right? And what is f of 1? 3 minus 4, so that's -1, right? So that is the final answer. Okay, and again, notice that here I'm not multiplying anything, right? I'm not multiplying f and g. So f circle g is not the multiplication. Okay, it's plugging in twice. It's not the multiplication here. And now f circle f of -4. Okay, so again, here input is a number. And you are plugging in what? The second function into the first one, right? Now, here though, what is the small issue? These two are the same, right? It's f of -4, right? Okay, now, which f do we do first? Always the inside, okay? So we always do the inside function first. So, what is f of -4? That's what, -12 minus 4, so that's what, -16, right? And now, is that it? No. Now what do you have to do? Plug in -16 into f once again, right? Okay. So what do you get? That's what, -48 minus 4? So this is what, -52, right? Okay, again, this is not f times f, it's f composed with itself. Okay, so we plug in -4 to f, and then whatever we get at the end, we plug that into f to get the final output. Okay, and now g circle f of 0. Okay, so now here, what do we take care of first? G or f?
F.
F, right? Yeah, always we go backwards, okay, like that. And input is a number. So this is g of f of 0, which we do f of 0 first. Okay, and now what is f of 0? F of 0 is -4, right? -4, but that's not the end, right? Now what do you have to do? Plug in -4 into g. So what do you get? 8 plus 1, so that's 9, right? Okay. So any questions over these finding function values using the composition? Okay, so it's not that terrible. Again, what most people make common mistake is this order. Okay, what is done first? But remember, in composition, we are going backwards. Okay, plug in the second function into the first one, not the other way. Now, here comes the key parts. F circle G and G circle F, the general functions and their domains. Okay, so now, since we cannot see f and g, let me copy it here. So f was 3x minus 4 and g was negative 2x plus 1. Okay, so what is f circle g? Okay, so again, this means we will be plugging in g into f, right? Okay, not the other way. So this is f of g of x. And now, what do we do here first? Inside, right? Okay, and now what is g of x? Negative 2x plus 1, right? Okay, so this is negative 2x plus 1, but then there is f outside, right? And now, here is the tricky part. What does this expression even mean? F of negative 2x plus 1. What do we do here? So maybe seeing x here and x here can confuse people. So I think I have done this in the past. Now, do you see what to do?
Don't we plug the whole quantity in for the equations would be 3 times, negative x squared plus 1 minus.
Right? So do you see that? So that entire thing is the input, right? So what do? Replace that x or smiley face, whatever, by negative 2x plus 1, right? Yeah, okay. So this means we replace x in f by negative 2x plus 1. Okay, so what does that mean? 3 times negative 2x plus 1 and then minus 4 in the back. Okay, so we can clear parentheses here. So we get negative 6x plus 3 and then minus 4. So we get negative 6x minus 1. Now, what is very common mistake that people make is they set that equal to 0 and solve. Okay, now please don't. Please don't. That is it. Okay, you never set something equal to 0 unless you have to. Okay, please don't overthink. Now, sometimes overthinking can help you, but in many cases, it hurts people. Okay, so never set it equal to 0 and solve. Okay, now, what is the domain of this negative 6x minus 1?
Wouldn't it be everything?
And what's the reason? No square root, no rational, right? Yeah, okay. So the domain is everything, yes. And now, you flip f and g. So g circle f and its domain. Okay, so now here, what do we do first? G or f? F, right? Okay, remember always the second function has to be done first. So this is g of f of x, right? And then we do f of x first. So it's g of 3x minus 4. And now, what does this even mean? So can we use the same approach as we have done in part D? But it's slightly different, right? So what does that mean? Here, what's the input? 3x minus 4, right? Okay. And then where do you plug this into? g, right? Okay, by 3x minus 4, right? Okay, so what do you get? Negative 2 stay the same, right? It stays the same. And then instead of x, you have 3x minus 4. And then you have plus 1 in the back, right? Okay, so what is this? Negative 6x plus 8 plus 1, right? Okay, so what is this? Negative 6x plus 9, right? Okay, and again, once again, don't set this thing equal to 0 and solve. That's it. That's it. And now, what is the domain of this?
Everything.
Still everything, right? Yeah, okay. Still everything. Okay, so now that was number 7, which was not that long. And now number 8. So here apparently the key parts are finding the general composition functions and their domains. So look at number 8. It says repeat parts D and E on number 6 above. Here's the typo. Number 7 above for the new pairs of functions. Okay, so now part D and E was what? Fog and golf and their domains. Okay, so let's start with F circle G. Okay, so F circle G means what? F of G of X, remember, plug in G into F. Okay, and now what do we do first? The G, right? Okay, so what is this? F of 2x plus 5. Okay, and now what does this mean? Plug in 2x plus 5 into what? F, right? Okay, so replace x in f by 2x plus 5. So what do you get? Square root stays the same. And then it says x minus 1. So what is that? 2x plus 5 and then minus 1, right? Did you get that? Okay, and what is this? Square root of 2x plus 4, right? Okay, and now, is this equal to x plus 2? Like, you divide 2 and 4 by 2, which is kind of the square root thing? No, okay? And you cannot split the square root whenever you have a addition under the square root. Did you know that? So this is not equal to this, right? Okay, so what does that mean? That's all. Okay, so that is all for F circle G. And now, what is the domain? How do we find the domain, basically, for the square root?
Set what's inside the square root equal to 0 and solve.
Not equal to 0.
Oh, greater than or equal to.
Right, greater than or equal to 0, right? Yes. Okay. And then you solve. So what does that mean? You minus 4, so you get 2x is greater than or equal to negative 4, right? And then divide by 2. Change the sign or no? No, right? So what do you get? X is greater than or equal to negative 2. And what's the interval notation of that? Negative 2 comma infinity with a bracket around to negative 2, right? Okay. So that's the domain for F circle G. And now go backwards. Go backwards. And what does that mean? G circle F. Okay, and now what does G circle F represent? So that means we are plugging in F into G, right? Okay, so what is this? G of F of X, which we do F first. And what is this? G of square root of, oops, X minus 1. And now, what does G of square root of X minus 1 even mean? That looks awful. What do you do here?
Replace the x in g.
By,
Square root of x minus 1.
yeah, still the same thing, right? So even though we have a square root, that's okay because that entire thing is the input, right? So what do you get? 2 stays the same from G, right? And then instead of X, we have square root of X minus 1 and then plus 5 in the back, right? Now, here, can we simplify this further? So, namely, can we add -1 and 5? No, right? Because that's under the square root, right? And we cannot add 2 and 5, right? Because that's multiplied to the square root. So that's it. Now, what is the domain? Or how do we find the domain? So here, can we use the same approach as before? I mean, yeah, we can use the same method, right? But what is different? What's under the square root is different, right? Okay, so instead of 2x plus 4, what do we have under the square root? Just x minus 1, right? Okay, so what does that mean? X minus 1 is greater than or equal to 0. And so what is this? X is greater than or equal to 1. So the domain is what? Bracket 1 comma infinity, right? Okay, so does this mean the 2 and 5 don't affect the domain? Right, they don't. Okay, and in particular, this plus 5 only affects the range. But the good thing is we are not finding the range, which is harder. Okay, so that is part A. Can I go to the next page? Okay, so the next page only has one problem, and that's it for this section. So here is part B, 2 over x squared for f, and then x minus 1 for g. Okay, and remember we are finding the exact same two things, f circle g and g circle f. So f circle g. So this means we plug in g into f, remember, we go backwards. So this is what? F of g of x, which means we do g first. So that means f of x minus 1. And now what does this mean? Replace x in f by x minus 1, right? Okay, so where is x in f? So 2 at the top stay the same. And then instead of x squared, 1 needs to be squared. That right? Okay, and now if you want, you can fold the bottom, but you don't have to, so that's okay. And now, what is the domain? Is it everything? I don't think so, right? Because that is the rational function. Okay, so how do you find the domain? We have to set the denominator equal to 0, right? So find the bad values, right? Okay, so now from here, x minus 1 squared equal to 0. Can you see what the value of x is? 1, yes. Do you see why? So now here, you don't have to follow the left-hand side still. And what's the reason? This is x minus 1 times x minus 1, right? And that's equal to 0, so what does that mean? Each of the two factors has to be a 0, right? But they're the same. So x is equal to 1, right? So in particular, x cannot be equal to 1, so 1 is the bad value, right? So what's the domain in words? Everything but 1, right? Okay, everything but 1. So what's the domain? Negative infinity, comma 1, and then 1 comma infinity. Now, what are the symbols?
All parentheses.
And in between the two intervals? The u, right? Okay. And now go backwards, G circle F. So this means we plug in F into G. So it's G of F of X, which means we do F first. So what is this? G of 2 over X squared. Okay, so what does that mean? We replace X in G by 2 over X squared, but that's just the same thing as what? This, right? 2 over X squared minus 1. Okay. And of course, you can express this into a single fraction using the LCD, but I'm not going to do that because that's not a hard task. And now, how do you find the domain of this?
We can't see that side.
Now can you see it? Oh, you mean this side?
No, the side you're working on.
Yeah, here, right?
Yeah.
Yeah, okay. So again, the g of f of x is g of 2 over x squared, which is equal to 2 over x squared, and then subtract 1 in the back, right? And now, is the domain everything? Can you see what the bad value is?
0.
0, yes. Do you see why? That is the denominator, right? So x squared is equal to 0. So what does that mean? X has to be a 0. So x can't be a 0. So 0 is the bad value. So negative infinity comma 0, and then union 0 to infinity is the domain, right? Okay. So what do you notice? The order matters, right? Okay, F circle G and G circle F. The order matters because when you swap their orders, you will get a different answer, okay? So be careful with the order. You always go from second to first in the composition case. Okay, so any questions over this 2.8? Now, let me jump to chapter 4, and then I will cover section 4.1 only, and then I'll come back to chapter 2. Okay, remember I'm kind of jumping back and forth in this course. Now, here, 4.1 will look at inverse functions. Now, there's a little note underneath that title. You can use a calculator, but that's actually false. Actually, like it's not false, but calculator will not help you basically in 4.1. Okay, so it's actually a non-calculator section. Okay, so now even though we can you can use a calculator in chapter 4, 4.1 is basically non-calculator section. So that's why I'm covering it right now, along with 2.8. Okay, so now in English, the word inverse means what? Opposite, right? Okay, going back basically. So how can we use inverse in functions? So here are the two definitions of the inverses. So number one, in terms of the relation. Do you remember this word before? Okay, not like romantic relation, right? It's the relation in math. So what was the relation in math? Set of ordered pairs. Remember this? Yeah. Already forgot because we covered that like 1,000 years ago. So now a relation, the name is G, capital letter G, is the inverse of another relation, namely capital F, if it satisfies these two conditions at the same time. Condition number one, F and G contain the same number of points. Okay, so the number of points in F and G must be the same, but that's not enough. And, okay, so that's condition number one. And condition number two, the points in one of the relations, say G, are obtained by swapping coordinates from the points in F. Okay, so the points in G are obtained by changing coordinates, so changing x and y coordinates from the points in F. Okay, so what does that mean? For example, like from like this point, 2, -3, how do you swap the coordinates? You get -3, 2, right? Okay, like that. Okay, so that's what I mean by the second point, swapping coordinates. Okay, so for example, if this is in F, that will be in G. Okay, and vice versa, of course. Okay, so now that is the relation definition of the inverses. Now, what about the function? G is the inverse function of f of x if there are two conditions satisfied. Have we seen this f circle G before? Yeah, like what, 10 minutes ago, right? Or what, 2 minutes ago, I guess. Okay, yeah, we just saw it, right? So what does that mean? We plug in G into F, right? Now, this means we plug in whatever X is into G and then F, but that is same thing as X at the end. So where you start is where you end. But that's not enough. We also saw that order matters, right? F circle G and G circle F. What happens when we swap F and G? So we have G circle F. Remember, we will plug in F into G this time, but the destination is the same. G circle F of X has to be equal to X at the end as well. Okay, so that is the function definition of the inverses. Now, there is a special notation for the inverse function. And the notation for the inverse function is this. has anyone seen this notation before? F with superscript -1. Okay, no one. Okay, so now this is very popular. Now, this -1 is not the reciprocal. Okay, that's just the notation. And how do you pronounce this? F inverse. Okay, it's not F to the power -1 or even F -1. Okay, it's F inverse. And please don't ask me why that's the notation. That's invented by people in the past, not me. Okay, so I'm not the guilty one. Okay, okay. I know it is weird, and I cannot answer why that's the notation. Ask people in the past who are much more brilliant than me. Okay, yeah. So now let's work on these following problems. Determine whether each of the following has an inverse relationship. So that means, in short, are they inverses? So part A. So you can see that there are what? Relations, right? Set of points. Okay, so these are the relations. Okay, so now what do we have to check? These two, right? So now, are they inverses? Okay, why not? Which condition fails?
They don't have the same number of points.
Right? So F has 3 points, right? -2, 2, -1, 1, and 1, 3. Whereas G has 2 points. They're not the same, right? So no. Okay, and that's the neat thing about this definition. If one condition fails, you do not need to check for the condition number 2. If one condition fails, entire thing is bad. Okay. And now, part B. Are they inverses? Yeah, it should be, right? Because part A was no, so this better be yes. But let's see why. Okay, let's see why. Number 1, F and G both have how many points? 2 points each, right? Okay, so condition 1 satisfied. Now, is the points or are the points in one relation obtained by points from the other by swapping coordinates? Yes, do you see that? Swap -2 and 2, you get 2, -2, right? Swap 1 and 3, you get 3, 1. Okay. Points in G are obtained by swapping coordinates. From F. Okay. So by these two conditions, or by these two regions or reasons, yes, they are inverses. Okay, so it's fairly easy to tell when we are given a relation. Now, starting part C, we have a function or functions. Okay, so what do we have to check? We have to compute what? What we just did, right? F circle G and G circle F. And remember, they all have to be equal to what? X at the end, okay? Which is the simplest case. So let's compute F circle G. Okay, so now we know what to do because we have done like a million problems until now. So what do we do? Plug in G into F, right? Okay, and what is this? F of G of X And we take care of g first, right? And what is this? F of 1/2 x minus 5. Okay, and now what does this even mean? F of 1/2 x minus 5. We plug in what? 1/2 x minus 5 into what? The x in f, right? Okay, so what is this? 2 times 1/2 x minus 5 and then plus 5 at the end, right? Okay, so now how do you clear parentheses? That, right? And now when you clear parentheses, what is the number in front of x?
1.
1, right? Because 2 times 1/2, they cancel, right? Yeah. So it's x minus 10 plus 5. So what do you get? X minus 5, right? Now, is this equal to x? Remember what we want is what? Just x, right? Not x minus something. So what does that mean? That's not equal to x, right? Okay, so now, do we need to find G circle F? No. Why not? Because condition 1 is already failed, right? So we don't need to find G circle F. Okay, so no need to find G circle F. Again, what's the reason? Because condition F is failed, right? So what's the answer? No, they are not inverses. Okay, remember, if condition 1 or 2 fails, you don't need to check for the other condition because it will be bad anyways. Okay. Okay, so now part D is on the next page. Can I go to the next page? Okay, so now part D. 2x plus 4 is the f of x, and g is 1/2 x minus 2. So again, we have to find f circle g. So what is f circle g? This is f of g of x, which we do g first, right? And so what does this mean? F of 1/2 x minus 2. Okay, so we plug in 1/2 x minus 2 into x in f, right? So what is this? 2 times 1/2 x minus 2, and then plus 4. Okay, and now, to clear parentheses, we distribute 2. So what do you get? X minus 4 plus 4, right? You see that? And now, simplify this. So these two cancel, and that's equal to x. Now, is this a good sign? Oh, yes. So we are very happy because we got x, which is what we want. Now, does that mean f and g are inverses? We don't know yet, right? I mean, it should be based on how the problem is going, right? But we don't know in general because we still have to check G circle F. Okay, so here what do we do? Plug in F into G. So it's G of f of x. So what is this? We do F first, and that is G of 2x plus 4. Okay, and that means we replace x in g by 2x plus 4, so it's 1/2 times 2x plus 4, and then minus 2 in the back. So distribute 1/2. So what do you get? X, and then plus 2, and then minus 2, right? Okay, and these two cancel, so it's equal to x. Okay, so now, is this a good sign? Oh, yes. Okay, so that's kind of looks like a creepy face, but whatever. So what's the answer? Yes, they are inverses. Okay, because we both got x at the end for f circle G and G circle F. Okay. Okay, so any questions over these problems? Okay, so now we couldn't quite go fairly deep on this section, but we can easily finish it on Monday. So on Monday, we will finish up this section and then we will go back to chapter 2 and then cover about maybe a section or so. And then on Tuesday, we will cover 2.6 and then 3.1, hopefully. And then remember our exam 2 is scheduled to take place on Wednesday. And at this point, I will stick to that. But if I happen to change it, I'll let you know. But at this point, that's the date. Okay, and if you have any questions, feel free to ask me. And if not,